All right, ladies and gentlemen and everybody, let's get started. Let's quickly just come through.
I just had the dentist come and decimate my class and leave me with 6. Here's what we're doing.
Yay. Yeah. Alrighty. Well, let's hope that doesn't happen to us. All right, so what I need you guys to be doing right now is to go to Google Classroom. We are going to be looking at lesson number 8, the combination reaction practice task. So that's the lesson that I want you guys on. So Google Classroom. I'm just going to go over the instructions so you guys can see the same thing that hopefully is on your screens. And in fact, I can check to see if you guys have the same thing on the screen. Some of you guys have already opened some of the assessment up, which is fine. Yes, I can see what you guys have open. Funny that. Yeah? What do you mean, difference between sulfur? Yeah, very different. We will find out. All right, are we ready?
Yes.
Okay. So what we're looking at for our combination practice 1, we are going to be doing this for today's lesson and also on Thursday's lesson with the plan for Friday to start the part B of the selected chemical reactions internal. I know some people have been away. I know some people have recently joined the class, and so please talk to me and we'll have a negotiable deadline for those that have had issues with absences and things like that, okay? But for most people, you guys should have had Part A completed and you should have handed that in. You can work on both of these simultaneously. It's the same kind of ideas. Huh? What? It is a similar test, different reaction. Okay? That's why I'm saying you can work on both of them at the same time. Yes. All right, so with this reaction, some things to keep in mind. Each one of you guys should have a copy of the practice combination Google Doc, which is what's opening right now. The other things that I provided for you guys is some, again, the notes. So these notes here describe what a chemical reaction is. This one here I posted before. It talks about the types of chemical reactions. Remember, I'm giving you guys these resources because it is an open book assessment. You are allowed to use your notes, and so you can reference these documents here. Plus anything else that's on Google Classroom and stuff that's in your notes. Now, with the combination reactions, a lot of them we can't do safely in the lab for various reasons, or they need to be done under teacher supervision to make sure that they are very carefully completed. So, that's why for a lot of these we have some videos of what we are reacting together. And in other instances, you will be able to do the reaction, but it'll be small groups with teachers, or with me, the teacher, observing and providing support because we don't want any accidents. Are you okay with that so far? Yeah. All right. So I will do one as an example, and then you guys will have 3 that you can do for practice. When it comes to these guys, all of these will be via video examples. So just keep that in mind that we're not getting any of the practical reagents out for today's lesson or Thursday's lesson. So we're just going to watch the video at different places and do the same thing that we've done before, making our observations, identifying products, identifying the type of reaction, and also doing equations and things like that. Keep in mind that The red component is what I'm writing for achieve. This is what you need to have in order to pass. The blue component is what you then need to add if you want merit. So if you are aiming for merit, you need to have everything that's in red plus the stuff that's in blue. And if you're aiming for excellence, you need everything in red, blue, and green. So basically everything that I've written down. The other thing you need to keep in mind for the excellence is that there is a comparison paragraph that you need to write, comparing between precipitation reactions and combination reactions. So these are the two that we have focused on. So this is our example here. We are dealing with sodium, and we are reacting with, oh, made it a little bit too big. Now you can't see it anymore. There we go. With chlorine gas, and this is our product. We have a video to watch this reaction because unfortunately,
when you get your next big idea, say
Grammarly.
Grammarly's tone suggestions can help pitch it with confidence to get your team on board.
Did you see her email?
Already complimented.
Because no sandwiches.
There we go. Let me start that over, and let me make that a lot quieter so it doesn't blow your ears out. Alrighty. Cool. So, with this reaction here, we have sodium metal and chlorine gas. Any idea why I'm not doing this in class right now in front of you guys?
We know the very right.
We don't have the metal. That's one reason. The metal is highly, highly reactive. It's actually quite dangerous, and so under health and safety, it's not safe for us to store it at school anymore. It reacts very violently with water, so it's very easy for it to cause problems. What about chlorine? Why do you think you not have chlorine? Because you will die. Chlorine gas is really toxic. They've used it in the war as one of those reagents, and in fact, it is now illegal to use that as a war weapon. It's so dangerous. They decided that that's too far. So that's why we are not using those chemicals in class. Let me grab my notes real quick. Make sure I have what I need. And then go ahead and see. Alright. So let's first, so all the videos you are going to be seeing today are going to be online for various safety reasons. Same thing with like the sodium and things like that. Ooh. Here we go. Oh, now we can't hear anything. Sorry, don't know what's going on.
However, interestingly enough, when they are combined, they form a
Let me
nice
start over,
table
go.
salt. So this is my little setup to make some table salt, also known as sodium chloride. So just from the name sodium chloride, you can pretty easily see that it has two major components, sodium and chlorine. On their own, both elements, sodium and chlorine, are pretty reactive and dangerous. However, interestingly enough, when they are combined, they form a nice edible salt. This is an interesting demonstration that shows how drastically different the properties of a compound can be compared to its components. So for the first step, I'll cut off a small piece of sodium that I'm going to be using for the reaction. Sodium metal is actually quite shiny, but it quickly reacts with air and moisture and forms a white coating. You can see a bit of the shininess after it's cut on the bigger piece. The liquid that you see dripping off the sodium is mineral oil, which is what the sodium is stored in. This is my chlorine generator. Inside the flask is chlorine pool pellets. I then poured hydrochloric acid into the flask and it reacts to produce chlorine gas. As you can see, the chlorine has a faint greenish yellow color. The top is blocked, so the chlorine is forced down the hose. The hose leads into a larger flask with sand at the bottom. The sand is at the bottom to prevent the glass from cracking from high heat. Inside the flask is then dropped a small pellet of sodium. This is half of the piece that I cut off in the earlier shot. A little water was added to get the reaction started, but I think I added a bit too much.
And that's why we don't do that.
The white cloudiness that you see is a suspension of really small particles of sodium chloride. The white stuff on the walls is also sodium chloride. When a lot of the sodium chloride cloud has dissipated, it's a lot easier to see a lot of the white sodium chloride all around the flask. I decided to try it again, but this time putting much less water to see what would happen. It took a bit longer to get started and there was more flame, but it wasn't too impressive. It was pretty short-lived and it wasn't very spectacular. Maybe it would be better if I used more sodium. The interesting part is that with the second run, since the sodium stayed in one place, I was left with a solid block of sodium chloride at the bottom. Unfortunately, because the sodium was reacted in sand, it's highly contaminated with it. So you can see here that when it's broken up, that a good portion of it is sand. I really did want to get the sodium chloride as pure as possible, so I opted to carry out the experiment again using the second most common method. This involves heating the sodium up until it melts and lowering it into an atmosphere of chlorine. This way, I wouldn't need to use sand and I could probably get a much purer product. Because no sand was required, I opted to do the lazy method, which is putting the chlorine pellets at the bottom of the flask and simply pouring hydrochloric acid in. To lower the sodium in, I made somewhat of a ghetto little contraption which involved a broken test tube and an alligator clip. The sodium was placed at the bottom, and then using a torch, I melted it. I heated the sodium until it ignited, but when I lowered it into the chlorine, it went out, which was quite surprising for me actually. Despite it going out, all of the sodium that was exposed to the chlorine became nice white sodium chloride, but unfortunately this is not the spectacular reaction that I was expecting. I took the sodium back out and I heated it a lot until it was molten red. This time, when I placed it back into the chlorine, it was a much more spectacular reaction. The sodium burned really bright and it turned my Erlenmeyer flask into a lantern. From demonstrations and other resources that I've seen online, I honestly expected this reaction to last no more than a few seconds. I'm not sure if I just used more sodium than the other demonstrations, but the reaction seemed to go very vigorously and bright for at least a minute. Now that the reaction had died down, it's possible to see the reaction going on inside the broken test tube. Compared to the other method where it was ignited using water, this method produced a lot more sodium chloride smoke. The test tube was coated in a thick layer of nice white sodium chloride. I tried to scratch off as much as I could, but it's honestly very hard and stuck very tightly to the glass. When it's poured out, you can see that this product is much cleaner than the last run. This sodium chloride was surprisingly fluffy, maybe because it wasn't contaminated with so much sand. Although this product looked nice, white, and clean, I still highly advise that you don't sprinkle this onto your food.
Alright. So, like I said, that was our first kind of video that we were looking at. When we start off, one of the things we need to do for the achieved is making our observations. I'm just going to change that into our red color because we need to do that in order to pass. Alright, so first thing to kind of ask ourselves is what state do we see the sodium in? Is it solid, liquid, or gas? So it's a solid. Why is that so pale? There we go. All right, so we have a solid. And when we describe that solid, is it shiny or gray? It's shiny. Sorry, shiny or dull. And what color is it? Gray. So we have a solid that's a shiny gray. All right, observation-wise, for the next one is our chlorine gas. So chlorine gas, when we are looking at it, solid, liquid, or gas? Gas. And what do we see about the color of it?
Green, and yellow.
Yeah, it's a pale green, it's a pale yellow. All right, then when we think about our product that we observed, we see what type? Solid, liquid, gas. Is it shiny? Or it's kind of dull now. Dull. What color would we describe it?
White.
All right. Cool. Are we okay with that so far?
Yeah.
All right. The next thing we need to do for the achieved is we need to name what that product is. So we have sodium and we have chlorine coming together. So that is sodium chloride. So I've identified it. That is my achieved. Please note that we have changed it from chlorine to chloride. The N is changing to a D because we're talking about the ion now, not the element. And you should be typing this into your example, so that way you have the notes for when you do the practice. All right, what type of reaction is this?
Combination reaction.
Combination, good. So this is a combination reaction. And then that's enough for the achieved. If I wanted to get my answer up to merit, what should I be doing?
Because.
Using the word because. So how do I know that it is a combination reaction? Because... how many reactants do I have? Two reactants, which are what? Sodium and chlorine combine to form how many products? One product. And what's our product? Sodium chloride. Yep. Let's add a little more detail. What are we starting with? Element, compound, or mixture?
Element.
Yeah, so we have, in this example, two elements have combined to form what?
Product.
What's the product? Element, compound, mixture.
Mixture. Compound.
Compound, because they're chemically bonded together to form one ionic compound, if we are being more specific, because ionic is what that is, because you have a positive sodium ion and a negative chloride ion. Are we good so far? All right, so that is our first one. The other thing we're going to need to do is our equations. All right, scroll down. All right. So our equations then here, we have our two reactants. Again, for the achieved, we need the word equation. So we're going to do sodium plus chlorine, two dash lines, and my little, this guy, the greater than symbol, to make my arrow. And then what was my product? Sodium chloride. That looks like it's going to be really teeny tiny. Let me fix that. What size is that? 10. All right. So we see in this example, we have the combination reactions. So we have our metal and our non-metal. I've included there, and then I've named the ionic compound. We've done lots of ionic compounds, so it's just following that same sort of ending. All right, sodium, what's the symbol for that? Na. Ooh, that's really tiny. Let me make that bigger for you. Don't know why it's so small. Why is that? What size are you? Cannot be 10. All right, let me make that bigger because that is redonkulous. Why it's so small? You can't read it. Oh, it's too big. Okay. Is that even centered? All right. Next one is chlorine. So chlorine gas should be Cl. And then we're going to do control, comma. Whoa. What did that happen? What is it doing there? Something is funky with these numbers. Hold on a second. There we go. I knew something was wrong. All right, that's my symbolic equation. Do you want me to walk you through how I got there? Do you want me to walk through the balance? Are we okay with how I translated it from word to symbol?
Oh, we need to.
Yeah, so chlorine gas is Cl2.
Yeah.
Because it's a compound. Or sorry, not a compound, it's an elemental molecule. Are you okay with how I translated that over? Are we okay with how I got sodium and chloride as the ions in those ratios? Yeah? All right. So when it comes to balancing it then, I want Na plus, I'm just going to copy the equation over first, and then figure out how I need to fix it. Are we okay so far? So I've just copied the equation we had before. I'm going to make it a little bit bigger so you can see it. All right. Now, let us go through and count each one of our atoms. So sodium is 1. Sodium on that side is 1. Is that balanced?
Yes.
Yeah. Chlorine on this side is 2. Chloride on that side is only 1. Is that balanced?
No.
No. So what we are going to be adding is coefficients, which are only added in front. So I'm going to put what number in front of NaCl? 2. But then I've made a problem, haven't I? So now my chlorine's a balance. Is the sodium balanced? No. So what I need to do is sodium. 2 in front as well. Now that is balanced. We good so far? What I'll do is I'll make some practice problems and I'll post those up because I haven't had a chance to, just so you guys can practice the combination reactions, how to word equation them, symbolic equation them, and balance them. Sound like a good plan? Okay. All right. Looking through the other examples that you guys had, are there any things that you want help with? So this one here we see sodium again. This one we see oxygen gas, and you see how on not test tube, the jar, that it has an O2.
Who's the H?
It's not water. Water is H2O. But I'm just pointing out, you see how oxygen has an O and a 2 next to it. So it's like chlorine, how that was the Cl2.
This is part B.
This is part B. You're doing some practice. All right, here's the iron, here's the sulfur. Remember, sulfur is different from sulfate, because sulfate is SO4 2-. And the last one here is you have magnesium and you have nitrogen gas. Nitrogen gas would also be an N2. Okay? So you have the rest of the period to get this done. I'll also give you the next lesson as well, just to do some practice. That's basically it. Questions, concerns, comments, anything you want me to go over again? No? All right. I'll get some headphones out so you guys can listen to those videos too. Yeah. That one? So with the explanation, you're just explaining to me what a combination reaction is. And I think in all these reactions that we've given you, they're all 2 elements forming 1 ionic compound, so that makes your life easier. Cool. I'll leave you guys to it. You have, like I said, 3 reactions to practice and lots of videos you can watch.
And it's due on Friday.
So Friday is when we're going to do part B.
We can do this at home, and
Yep. So this is the practice one to prepare you for part B. So this one, you can write up your answers. I can give you feedback and can tell you if it's right or wrong. Friday's one, I can't do that. Okay? So do your practice now. And when you do your actual assessment, you can refer to these as notes. So it's really worthwhile to finish it and get it checked off by me. Okay?